Good morning all. Welcome back to next lecture. In the last lecture, we discussed the application of graph, especially budget line in consumer behavior analysis and iso-cost line in producer behavior analysis. See, economists often concerned with analyzing the cost and effect relationship among the variables. And among these studies, see, they are also concerned with the magnitude of effect of two variables under the consideration. And in analyzing these, see, economists often uses two important concepts, which is marginal effect and average effect. So here we will discuss the marginal effect and average effect in detail. After advent of the marginalist school of thought, one of the most widely used concept in economics is marginal concept. We are aware about the concepts of marginal utility, marginal cost, marginal revenue. See, we are regularly using in economics these terms. So marginal concept actually helps to find the slope of a function. And it shows that how much change is happening in one variable due to changing another variable. So geometrically we can say that it is delta y by delta x, that is it is the amount by which y coordinate of the point in the line changes when x coordinate is increased by 1 unit. And mathematically the marginal effect is the first derivative of the function, and that is dy by dx, that is derivative of y with respect to x, which actually measure how a small change in x due to the changes in the y. So when it comes to the geometry, the first derivative of the function is nothing but it is the slope of the curve. It is the slope of a function, or it is the slope of a curve. So in the linear equation, we have discussed the form of, generally it is y is equal to a plus bx format, where the symbol has the meaning. Earlier we have told, see, b is the slope of the coefficient, or it is the slope coefficient. And when it comes to the marginal school of thought in economics, see, b is having different meaning, that is known as it is marginal effect, which is known as a marginal effect. B is nothing but it is the marginal effect, which means that the change in outcome variable resulting from a small change in one independent variable. So holding all other variables are constant. So here A is the intercept term and B is the slope, but here we are representing it is the marginal effect by keeping all other factors are constant. Now let us see one example. We can explain this concept by using an example. See, in Keynesian consumer theory, the consumption function, you might have been aware about this particular concept, that is consumption function, that is consumption is a function of level of income. C is equal to function of y, which means that as the income changes, the consumption is also going to change. And this relationship conventionally we are expressing that C is equal to A plus by. C is equal to A plus by, where A is the autonomous consumption, or it is intercept coefficient, and economics we are saying that it is autonomous consumption, which means that the amount a typical individual will consume when his income is 0. That is, when income is 0, that is y is equal to 0, then how much amount of consumption will be there, that is A, which is generally known as it is autonomous consumption. And the term B, which is earlier we discussed, it is the slope coefficient in a linear equation. Now we are going to take it as an economic interpretation, that is it is marginal propensity to consume, which means that the amount of change in consumption when 1 unit change in income of the consumer. So it is showing the proportion of increasing consumption because of the increasing their level of income. How much increased income will be utilized for the consumption purpose, which is actually captured by the slope term, that is marginal propensity to consume in this particular example. Now, Let us look at numerical example here by considering an income consumption function by giving here a input output table, and we want to find out the marginal propensity to consume. See, in the table, the income of the consumer is given and consumption is also given. When the income of the consumer was 200, the consumption was also 200. When income was 400, the consumption was 360. When income is increased to 600, the consumption is increased to 520, and so on. When income was increased to 1000, then consumption is 840. And what this particular table is showing, that is, as income of the consumer is increases, then consumption is also increases, and that means there exists a positive relationship between the consumption and income level, and suggesting that a higher level of income leads to the higher level of consumption. Now, from the given income consumption table, we are going to some coordinate points so that we can graph it, or we can draw the graph of this particular income consumption curve. See, the points here, it is when income was 200, consumption was also 200. So, it is 200, 200, 400, 360, 600, 520, 800, 680 and 1000, 840. And these are nothing but the various pairs, and we can plot these pairs. So, each pairs of the values represent here the point on the graph. So, first values in the each pair is nothing but level of income, and the second values corresponding to the level of consumption. So now these points can be plotted on the graph paper so that we can visualize the relationship between the income and consumption. See, the plots are taken here separately, when 200 and 200, 400, 360 and so on. Now we can plot the input output table to the graph by following the conventionally, we are taking the dependent variable on the x-axis and independent variable on the y-axis. Here income is taken along the x-axis. Here income is taken along the x-axis and consumption is taken along the y-axis. See, now we are going to plot these points here. When income was 200, consumption was also 200. When income was 400, then consumption was 360. When income was 600, then consumption was 520. When income was 800, then consumption was 640. When income was 1000, the consumption was 840. So we have a different points are plotted here, and we can join these plots so that we will get a income consumption curve. So once we sketch the data into the graph, we will get this type of straight line, and this is nothing but it is income consumption curve. The relationship between income and consumption appear to be here a linear, that is, the points generally follow a straight line pattern indicating a consistent increasing consumption with each increasing the level of income. So now consider the slope of the line. The slope of the line we want to consider between 2 points. So slope of the given line or the given income consumption curve can be found out by drawing a triangle here. For example, we want to find out the slope between the point B and point C. So we are drawing a particular triangle here, and then we will measure the slope of this particular point between B and C, which is measured by drawing this particular triangle, and then we will go for calculating this particular slope by using the formal equation, that is change in y divided by change in x. Slope is equal to change in y divided by change in x. See here, y is the difference between y2 minus y1 and x2 minus x1, and we know x1 and y1 is equal to the point B and C. At the point B and C, it is 400, 360, and x2, y2 it is 600, 520. So if you substitute these values on the slope equation, then it is 520 minus 360 divided by 600 minus 400, which is equal to 160 divided by 200, which is equal to 0.8. So by substituting the value on the slope equation, we reached the conclusion of, or reached the answer, that is slope is equal to 0.8. And what this 0.8? This is marginal propensity to consume, and which means that individual 1 unit increasing the income, the consumption will increase by 0.8 unit. So it is the proportion of your increased income which is, it is having the effect upon the consumption. So in a linear function, we can say that this is nothing but it is a marginal effect. This is a marginal effect. And the marginal effect or marginal value is remain constant over the graph or across the graph. Because the slope of the function, that is, which here we are representing, that is marginal effect, which is consistent throughout the entire range. Because since the slope of the linear function is constant, the changing in the dependent variable, that is changing in the consumption for given changes in the independent variable, that is change in income, is constant across all points on the graph. So therefore the marginal effect of a linear function or the slope of a linear function remain the same regardless of the level of independent variable. So here it is 0.8. So across the curve, across the income consumption curve, the slope will be same. The marginal effect is constant across the graph. Now we are introducing the another concept, that is average effect. See, economists often interested in knowing the average effect of change in independent variable x on the dependent variable y. And it is per unit change in dependent variable when independent variable is going to change. In our previous example, the consumption income curve relationship, the average effect of consumption refers to the overall impact of income on the consumption over a certain range of income level. So in a linear function, consumption function, the average effect of consumption typically decline rather than constant, as in the case of a marginal effect. See here, the average effect of consumption is typically declining as your level of income is increases. And this is because as your level of income increases, the proportion of your increased income spent on the consumption tends to decline. And the average effect is declining as the value of x increases, especially in a linear function. But the average effect, which we are already discussed earlier, which will remain constant across the graph. So geometrically, the average effect is again it is also equal to the slope of the ray. It is the slope of the ray which is starting from the origin to the function. Rather than we are making the triangle between the 2 points, we are drawing a particular ray. So as the range of x value increases, the average effect decreases or decline because the total changing in the dependent variable is over the range is spread over the large interval of x values. So this result in lower the average effect compared to the smaller interval. So geometrically we can say that average effect is the slope of the ray from the origin to the function. Now geometrically the average effect can be represented by the slope of the ray from the origin. And the ray from the origin, we know we are generally representing it is 0, 0, that is 0 value of x and 0 value of y. So at that particular point on the curve within the specific interval represents average effect of function over that particular interval. So this ray actually form a right angled triangle with x axis and the tangent line to the curve at the point. So here the slope of this particular ray is actually equal to the average rate of change of function over the interval. So it actually measures how the function is changes on average as independent variable or x axis changes. And by calculating the rise, that means vertical change over the run, that is horizontal change on the ray, you get the average rate of change, or it is average effect of a function over the given interval. We will consider some examples so that it will be more clear. See, we want to find out the marginal propensity to consume here, average propensity to consume here. It is average propensity to consume. Here the income consumption information are given. So as income is increasing, consumption is also increasing, and we have different points here by taking the income and consumption. So it is 200, 200, 400, 360, 600, 520, 800, 680 and 1840. So this is we are already discussed it, and this particular table, input output table or income consumption table, actually showing as income increases, the consumption is also increases. Now we are going to plot this income consumption table into the graph by following the conventional way of taking the dependent variable on the x-axis and independent variable on the y-axis. See, on the x-axis we are considering the income, and the y-axis we are considering the level of consumption. And now we are going to plot these particular points on the graph. So when income is 200, consumption was also 200. When income is 400, consumption 360. When income 600, then consumption 520. Then income was 800, then consumption 640. When income was 1000, then consumption is 840. By joining this particular point, we will get an income consumption curve, which we are already discussed. So we will plot this input table in the graph, and we have a sketch of the data into the graph, and we will get this type of a straight line which showing the linear relationship. Now earlier we discussed how to find the slope of the straight line between 2 points, that is B and C. See, by drawing a triangular between the point B and C. But here on the average effect, the slope is measured little bit different way. See, we will draw the triangle from origin rather than by joining 2 points. Let us consider the point A. We have a straight line. We sketched the data on the graph. We have a straight line. Since the average effect practically calculated by drawing the ray from the origin, we are drawing a ray from the origin to the point A, to the point at which we wish to find out the average value. So here the average value we want to find out at point A. So assuming we want to find out the average effect of consumption at point A, so following the convention, we will draw the ray from the origin to the point, and we will draw the straight ray to the origin from the point A and vertical straight line to the x-axis also. So we have a triangle here, and this ray will form a new triangle, right angled triangle, which is, we can say, OAC. So once we get a right angled triangle, we will go for conventional methodology for finding the slope, that is substituting the value into the equation of the slope. But here the change will be starting from 0. So let us consider the slope here. We know the equation. So it will be OA divided by OC. We are considering here. So it is delta Y divided by delta X. So when consumption was 200, when income was 200, consumption was also 200. We are taking the delta Y here, that is, it is 200 minus 0. It is Y2 here, we are assuming it is income level 200 with the origin. So it is 0 we are putting. So 200 minus 0, which is equal to 200. Then delta Y, it is again consumption is 200, but ray is starting from the origin. So we are putting it is here 0. So it is delta Y is equal to 200 and delta X is equal to 200. So 200 divided by 200, which we will get the slope, which is equal to 1. And this 1 means that it is on an average, when his income is increases to 200, he will consume his entire income. So here see, when his income was 200, his consumption is also 200. That means he is spending his entire income 200 on the consumption purpose. So that's why the slope is equal to 1 here. Okay. Now consider the another point on the graph, that is point B. At this particular point, we want to find out the average effect of consumption at point B. So following the convention, we are drawing a particular ray from the origin to this particular point B, and we will draw this straight ray to the origin from point B and conventional straight line to the x-axis, which is touching here on the x-axis at a point E. So this ray will form a new right angled triangle, which we can call it is OEB. So once we get such a right angled triangle, we will go for conventional methodology for finding the slope, and by substituting the value to the equation on the slope at the point B, where the points are 400, 360. So we are considering here the slope delta y by delta x at the point 4 income level, and consumption is 360. So it is 360 minus 0, which is equal to 360, and delta x is equal to 400 minus 0, which is equal to 400. The ratio of these two, we will get a slope. So it is 360 divided by 400, which is equal to 0.9. Earlier time, the average effect was 1, but here the slope is, or average effect is 0.9, which means that on an average, when his income is increases from 200 to the 400, he will consume the 90% of his income, that is 360, not the entire income as in the case of the point A in the earlier slide, which we are already shown. At that particular point of time, the average effect was 1, but here see the average effect is 0.9, which showing that the average effect is declining. So we are going to compare the average effect and marginal effect of a linear curve. See, in a linear relationship, what we are already shown, a linear income consumption function, the marginal effect represent a changing in the dependent variable resulting from one unit changing in the independent variable. Because the relationship is rational, the marginal effect is remain constant across the entire range of independent variable. And this means that, see, for every additional unit of independent variable, a changing in the dependent variable is same. That means marginal effect is same across the graph. However, see the average effect. See, average effect on the other hand, which refers to the overall impact of independent variable on the dependent variable. So over the range or over the interval. So in a linear relationship, the value of independent variable, that is as income increases, that means independent variable increases, average effect tends to declining. Earlier it was 1, then it was 0.9, then it may be 0.8, 0.7, like that. It is continuously declining. This is because an increasing in the dependent variable, that is consumption, is spread over the large range of the value of independent variable, that is income. So thus marginal effect of consumption is constant across the linear consumption function, but in the case of average effect, the consumption is declining as income increases in a linear consumption function, which actually reflecting that diminishing proportion of income which is spent on consumption. That means as per the Keynesian psychological law of consumption, which saying that as your income increases, then proportion of increased income spent on the consumption is declining. So which is actually capturing the average effect. But in the case of a marginal effect, which is constant across the curve. I hope you understood the differences between the marginal effect and average effect of a linear curve. Let me conclude here. In this lecture, we actually discussed some of the important applications of the graph in economics. Especially, earlier we discussed the budget line on the consumer behavior analysis and ISO cost line in the producer behavior analysis. Then besides that, we also discussed the average effect and marginal effect in the context of linear consumption, income consumption function. And thus marginal effect of a consumption is constant in a linear consumption function, whereas the average effect of a consumption function, it is declining as your income increases in a linear consumption function. I hope it was clear to you. We will see in the next lecture. Thank you.